questions, you're not going to get them answered. Yeah, and I don't have my Twitter stuff up here, but yeah, you could hit me up on Twitter. Okay, y'all ready? All right, excellent. Hey, thanks a lot for the introduction. Before I get started, I want to introduce two of my colleagues who unfortunately are not in the room right now. They're in another meeting. But there's George Carpenter, who's a principal solutions architect. He's the guy that kind of covers this area from a technical standpoint. And then his counterpart, Kevin Gallagher, is the strategic account manager. Him and George pal around, and they've got this entire this area covered for you guys. So if you have any questions about what I'm talking about, you can always hit me up after the fact. Both those guys will be back in the room here very shortly, and you can talk to them and get to know them. Great guys to work with. But in the meantime, let's get to it here. So before I get started, I just want to make sure that everyone is aware of HyTrust, and if I get in your way, anyone down here, tell me to move out of the way so you can see the screen. So how many are familiar with HyTrust today so far? All right, awesome. All right, so I didn't see many hands go up. So I want to, if you guys are familiar with HIPAA, you've probably heard of HIPAA HyTrust. That's HyTrust with an H-I. We are HyTrust with an H-Y. We are very different. We can help you with your HIPAA environment and secure that data that's in your HIPAA environment, but we are not associated with HIPAA from that perspective. We are a multi-cloud solutions, multi-cloud security solutions product. We can help you not only encrypt your data, but we can also help provide security and make sure that data that you're running in those clouds, whether it be on premises on VMware or out in other clouds, and you'll see some of those clouds pop up here on the screen shortly, make sure it's always protected all the time. Big shout out to VMware. We work very closely with VMware. We help enhance some of the capabilities that they already have in their products. VMware, to full disclosure, is actually an investor in our company, so we have some good relationships with them. You'll see some of our customers up here and some of our other investors, and then you've got I'm going to make sure this works. Oh, nice. So my green pointer works. You'll find the contact information for everybody up here up on the screen as well. And then one other shout out to VMware. You'll see that if you're not a vSAN customer, we actually work really closely with vSAN, and we help protect the largest vSAN infrastructure in the world today.
Who's that?
I'm going to leave that out for now to protect the innocent. I'm not sure if you guys are aware of it. Many months ago, you heard about the speculative execution problems that were out in the Intel chips. Well, guess what? 2 days ago, another one was just released. And what I have read in many articles is that unfortunately this is something that's not going to stop anytime soon, unfortunately. So it's going to continue to be patch after patch after patch. But the nice thing about it is that VMware was ahead of the curve, as well as Microsoft and AWS and Google and a lot of the other bigger guys were well aware of what was going on. And up here on the screen, you'll see all the different links, and you'll be able to get this stuff after the fact, obviously, because of recording. I can also share this with you guys. I don't know if you guys, for the VMUG, put anything up online, but we can give you a version of this as well. But VMware is well aware of this. They've got some updates for you, but I just want to add that into there so you know what's going on today. Also, shameless plug out to Jace McCarty. He posted some stuff recently on a presentation he did. These are two of his slides. If you're a Power CLI guy, these are different ways to go out and figure out just what you have set up and enabled in your environment for helping to protect against the old speculative execution attacks. And once you are aware of what you have, if you need to change anything, these are the Power CLI scripts to go in and change that information inside your environment, which is really nice. So let's get off the speculative execution stuff. How many of you, I'm going to jump in real fast. This is a product line, a product that we just announced last week, actually, around containers. How many of you today are using containers? I'll pop up my questions here. First question is, how many of you have a DevOps methodology or doing some sort of development in your environments today? Or are you doing IT infrastructure? So we've got a couple development organizations here. And for those guys who are doing this, are you doing any sort of DevOps container initiative inside your organizations? That's usually, I'm kind of hearing, I'm getting a mixed answers from everybody nowadays on whether or not they're doing containers or not doing containers. Well, anyhow, containers run everywhere, just like VMs nowadays run everywhere, whether that's VMware-based VMs or they're Azure-based or AWS-based VMs. They're all over the place. And so with that becomes security problems that we've all got to learn how to take care of. So this is some of the links that came out around our product. So I encourage you, if you don't know much about containers today, I'm here to help. I'm not going to give you a full rundown of what containers are and how to learn all about them. But we're here to talk about those and help everyone who's in the VMware space. I used to be one of you guys out there out in the crowd, so I know what it's like to do the day job that you guys are doing and then try to keep up on the new things that are coming down the pike. So this is a quick brief. The customer cloud journey is changing every day. You'll see that if you're doing anything, we're going to refer to this VMware cloud. That VMware cloud is most likely running on premises in your organization. But a lot of folks are starting to move, whether it's to Google, AWS, Azure, or IBM. There's data flying all over the place, and containers are also getting ready to be as persistent and pervasive as VMs are today. So the threat surface continues to expand with the adoption of containers and the public cloud across all organizations. So the HyTrust approach to securing that multi-cloud infrastructure and where those containers live today is to provide a unified visibility. So vCenter does a great job of providing you a visibility across all of your virtual infrastructure and helping you understand what's available and what you're using out there today. But when it comes to containers in the cloud, VMware's made some other great strides in launching and supporting access for different clouds out there. We're launching or we're adding to that for containers to provide you that unified visibility so you can have a holistic view of your inventory and your audit logs across not only your VMware infrastructure, but also your container and your Kubernetes infrastructure. And if you're like Kuber trust me, Kubernetes is going to be just as essential to you going forward when you start moving into the container world. We also are providing a unified policy today, and this is kind of jumping ahead about talking about security policy. We provide security policy across both of the products I'm going to mention this afternoon. But the unified security policy, we're extending that out into the cloud and out into the container organization. So what you'll be able to do is create a single unified security policy to help lock down and secure your VMware infrastructure, but also help lock down and secure your Kubernetes and your container infrastructure that you're going to be running no matter where that lives today or in the future. We're looking at doing continuous compliance, and what I mean by continuous compliance, I'm not sure what type of industries your companies are in today, but if you're in the financial space, you've got regulatory compliance rules you need to abide by. If you're in the Fed space or in the public sector space like higher ed, you also have, in the Fed space, you have even more regulations that you need to abide by, and those are pretty extensive, as well as many other industries out there. So we look at providing continuous compliance for your VMware infrastructure and your container and Kubernetes infrastructure going forward to make sure that when an auditor comes knocking on the door, you'll be able to get a full view of what's been taking place inside your organization, and then you can assure them that, look, we're doing everything we're supposed to be doing. And you can prove to them that there are no gaps in your cloud infrastructure. We refer to this, taking the first three, as full stack protection. So we provide protection for the VMware stack. Now we're extending that stack out into the cloud and Kubernetes. So that's why we're referring to this as a full stack protection. This is a view of our product that's talking about what workloads are running. So you all have a bunch of VMs. You know what types of applications are running across all those VMs. I know when I was in your shoes, the answer was an emphatic no. I have no idea what's running on virtual machines. But I'm taking care of the infrastructure under the covers to make sure it's secure and running all the time so to support the organization that we're all being paid by. The nice thing about our product is we can provide the visibility into them. And when it comes to containers infrastructure, there's the ability to pull down these images, which get instantiated into containers. And if you look on the slide here, you'll see one that says hub.docker.com. I've got a slide in the near future on my deck here that 190,000 Docker customers just were compromised through hub.docker.com. We're able to help you understand and lock down and make sure that you're not pulling in insecure images from hub.docker.com or other public registries. Docker is not the only one that provides public registries out there. We're also providing visibility into the vulnerabilities inside those images. So to step back quickly, I kind of assumed that you guys would know some of this information. When you connect to a registry, let's pick hub.docker.com, you pull down an image, and an image has multiple layers in it. So it's very slightly different than a VM. So a VM is a holistic container, let's refer to it that way, that has an operating system running in it. It's got networking. It's got a bunch of other stuff running inside it. And then you can move that all around. When it comes to the container world, basically what you do is you pull down images, and images have different layers in them. So there could be a base image that just has an operating system. And actually that operating system that is as a part of that layer actually has absolutely no networking, no firewall, no DNS. It doesn't have any of that information. It's just enough to fire up the operating system, and that's all it does. So then you start adding additional layers, like Nginx for a firewall, DNS for DNS resolving, DHCP for DHCP or to getting an IP address, and all kinds of those things. So that gets packaged up. Those layers get packaged up to an image, and that's where you can download those from hub.docker.com or any other public registries out there. Well, each of those layers or those images obviously get vulnerabilities. Not intentional, but there are some, because there's not always nice guys that we're always fighting against, that inject malware into some of those images. So we can, and some of those images or those layers of those images just get regular vulnerabilities, just like our operating systems and applications have vulnerabilities. So we can actually provide you visibility into the vulnerabilities in those images that you're downloading, whether they're coming from a public registry or you start building your own private registry, which is the recommended way to go. So here's that image I was talking about, 190 people. Just had the information from hub.docker.com exposed. Well, how can you stop that? I showed how we can show you where those images are coming from. Well, with our product, we can ensure that only trusted workloads or images come from a trusted registry. Typically, there's going to be a private registry. And we can, using our UI, make sure that no public registries are actually allowed. So your DevOps folks can't go out and just start sucking stuff off the network and then deploying inside your organization and potentially exposing you to some bad stuff going on in your environment. We also have the ability to say these of these registries that you have, you can only use certain ones inside the organization, and we can lock that down based on DevOps teams if you'd like to have that done. And then there are other ways of looking at vulnerabilities. What happens with images that have vulnerabilities? Do you have a high, medium, or low threshold? Maybe you can say that you only want to allow one high vulnerability in your organization. Maybe you can take 5 mediums and you'll take 10 low-grade vulnerabilities, and then decide how you want to slice and dice that on what you can deploy inside your organization. And then this is the zero-touch assessment and compliance, continuous compliance I was talking about. These are some of the different regulations. We've got templates built into our product, and you'll see those are built into our other products as well. So if you're in one of the organizations or industries that are highly regulated, we have templates to help you lock that environment down. And then you can do these scans on a regular basis to make sure that you're always continuously compliant. And then another thing, this is something that's fairly new to me, because I'm not a DevOps guy. I'm a, let's call me a really bad script kiddie. Not a script kiddie in a bad way, but I like borrowing, in parentheses, everyone else's code that's out there on the internet today to help get my job done. But it turns out the DevOps folks are much smarter than myself, and I'm not going to say of you guys, but definitely much smarter than me because I'm not a developer. They like to do things at the command line. We have a great UI, and so for our perspective, you can come in and build the policy based on the UI, or if you're a DevSecOps individual, you can also build the policy from a CLI or from a text-based method. And then the nice thing about this is you can then use things like GitHub and Bitbucket and other source code programs and capabilities to manage this security policy as well. So some of the benefits that come along with doing this is we help you avoid breaches across all your clouds with consistent security policies and all the clouds and options you see at the very bottom. We automate that security through security as code, and as you saw on the last screen. We also help you rein in your operational complexity. That happened a long time ago with VMs. It's going to start happening again with containers. The wave is just getting going. And then we're going to help you lessen the need for cloud security expertise by showing you how to secure that full stack across your organization. So with that, before I get going on to the next section, any questions from folks out there? Go ahead.
Does HyTrust work with organizations to determine risky levels? You mentioned earlier there were vulnerability of high, medium, low. Give an example of one high, a few medium, vulnerabilities. How do you reach those determinations? I know generally, CISO might say, this is my most riskiest, most coveted crown jewel. I want to protect that when I have that as my no vulnerabilities could ever exist here.
Yep.
But I would just know when you think about an executive, they're going to say they don't want any vulnerabilities anywhere.
Yep.
How do I make that determination? How do you work with companies to make that determination?
Yeah, so let me repeat that for folks who are listening or are going to be listening afterwards. The question was around how do we determine, how are we determining which are the high, low, and medium vulnerabilities in the within the images that I showed on the slides just recently. We're not making that determination. We're actually going by the CIS benchmark. I kind of skipped over. That's what we're using inside the product here. And so based on those, the CVE vulnerability database and the CIS benchmark, they're setting the threshold for those. And so we're going by those. Is that the answer you're looking for? Another question.
Yeah, as a follow-up to that, so you recommend using a
Private registry.
private registry, right? So a big organization, they're making their own images, their own Docker images. I'm not super familiar with Docker. Is there some metadata that you're reading from to say this image has this Apache version, and then you're referencing that against the CVE list?
Yes. Yeah, so the question is for folks listening afterwards is how do you determine what the vulnerabilities are inside those images, basically. Is that right? Yeah. So basically, yes, there is metadata around those images. And there are trusted images up on hub.docker.com. So the recommendation is use only the trusted ones. So Ubuntu and Red Hat and pick your app, your vendor are putting out trusted, well-known, safe images to pull down from the registries. So recommendation is to pull in those trusted, know what you're pulling down essentially. Pull down the trusted ones, bring them into your private registry, and then basically make the determination on whether or not you still want to use public registries for anything. So yeah, that's basically how that works. And then we're able to look inside the images. There's a way, it's beyond the discussion for here, but there are ways of figuring out, what are the different layers inside those images themselves. So let me skip over to the key control and data control. Another HyTrust product works really, really well with VMware. Well, I have a few questions here. Is anyone running vSAN out there today? I see a couple hands out there. Okay. And I'm not going to ask the version because really, it frankly doesn't matter. Are you running any of your VMs on other clouds? I haven't asked that about the container piece, but is anyone looking at other clouds today? And which ones might you be looking at? Just curious for conversation purposes. Yeah, go ahead. You're looking at Google? AWS? Okay, great. Yeah, I hear a lot of AWS. So you weren't a vSAN customer though, right? Just to for full disclosure, vSAN runs really, really well in AWS for you who's looking at AWS. We also are supporting AWS in our Cloud Control for Containers product as well. So we'll support containers running in AWS. But there's great reasons to look at that. The next question I have is, are you using encryption today across any of your environments? Are you using, and primarily I'm referring to data at rest encryption. Is anyone looking at that or using it today? I see no nodding heads whatsoever. Well, this is a great segue as to why my product is really relevant to folks who are not using encryption. So HyTrust Key Control is a KMIP compliant key management product. And what that really means, and KMIP stands for, it's actually not up here, stands for Key Management Interoperability Protocol. Oh, is it? Oh, it is at the very top. I have somebody move my eyes up all the way. So KMIP, we're a KMIP compliant key manager. It's an industry standard that's been around for longer than, I want to say 10 or 15 years. It's been around a long time. And key management is imperative for enabling encryption inside VMware products. We also support NetApp. We also support Nutanix. We support Pivot 3. Those are the ones I'm thinking of right off the top of my head. The slides have a few more as we get through there. But we can help manage the keys for those environments. It comes with a rich policy engine and a policy agent that I'll talk about in another couple slides here. And so it's one solution that enables key management across all of your infrastructure, whether that's on-premises, inside VMware, or if it even runs inside Azure or Google or AWS. We can provide key management for VMs that live in those environments as well. The HyTrust Key Control is a very well-hardened virtual appliance. Actually, every product that I'm going to talk about today is available in a virtual appliance only. We don't support any physical versions, physical hardware for our software. It's all virtual appliances. And when you're probably thinking about how are those encryption keys protected, well, they go into an object store inside our product, which is encrypted by a master key, and then there's an admin key that can be vaulted off to a hardware security module if you'd like to do that as well to provide additional protections. But it's not necessarily, it's not required to do that. So we also provide the ability to take the master key, the admin key that you see here, and break that up. And the reason for doing that is, let's pick myself. I'm a great admin. I do all my good, I'm doing my job, doing it really well, and then all of a sudden, I become a very bad admin. I become very disgruntled. Well, now I'm the one that owns owns access to the keys. Well, by adding, that means I could probably take that appliance with me. I then have access to the keys. I can fire it up, and now I can start decrypting things however I want, anywhere I want at that point. The recommendation is to have more than one admin, encryption admin, for your organization. So every time you add one, that admin key gets broken up into individual pieces. The great thing about this is that means if it's myself and Darren, I'm going to pick on Darren here. If it turns out I start going rogue, and say we have my other coworker, George, we're the three admins and we have access to the appliance, we're the super admins for the appliance. Well, it turns out if one of us starts to go a little wacko and get disgruntled, and we decide to take a copy of the VM with us, and we decide we're going to take it home and take a couple other VMs that are being protected or encrypted by the product, well, it turns out when I take it home, the appliance is going to realize it's not in the same environment it was in before. It will go into a lockdown state, and it will require the admin key, and it will require n of m numbers of those keys. And I may have said that backwards, but anyhow, if we have three key parts, we're going to make a policy that says that at least two of them must be available in order to power up and unlock the master key in the object store in order to gain access to the encryption keys in there. So that's a really powerful and very important thing to think about as you build out your encryption strategy inside your organization. We also have role-based access controls inside the product. We've got three different ones. One is a security admin. That's what I was referring to as a super admin. It has access to do everything inside the appliance. We also have the ability to do the domain admin, which manages just the nodes themselves, the virtual appliances, and backing up the key management product and the object store. Then we have cloud admins that can help manage cloud VM sets. Cloud VM sets are basically the logical construct for grouping VMs together and stating that all of these are being managed by an individual cloud admin. And if I decide that inside my organization, so for the finance, I have a finance cloud VM set, and maybe someone in the finance group can manage the encryption for those VMs. But that same finance admin can't manage any encryption for the VMs to be encrypted by the DevOps cloud admin. So it gives you the ability to lock that down and provide additional access and security. And then before I jump into the next piece that I kind of glossed over here, key management, as I mentioned, is very good for enabling. So vSAN and vSphere back in the 6.5 days came out with encryption as an option in the product. However, they have no key manager. That's where we come into play, and many others come into play. But we are actually the number one recommended key manager for enabling encryption inside VMware. And I'm going to show you a quick video here on just how easy it is to enable vSAN encryption inside your organization. Now, I'm sure you guys are well polished VMs. You've deployed an OVF, so I kind of skipped past that piece. We've already deployed it. We're powering up the virtual machine. We're now going to set the system password for the product. That's just a password to get access to the CLI of the product. And actually, it's a hardened OS. You actually can't get root on the appliance, and nor can we as HyTrust employees get access to that, even support. But you can enable that. Once you set that, you continue booting up. You'll get logged into the user interface, and if you saw on the screen here as I'm talking a little bit behind, you'll log in with the secroot password, user ID and password. You have to change that. Once you get that all set up, accept the EULA. We're now going to turn on the KMIP server inside our product. Once you enable that KMIP server, you'll see up here, we're going to then take that piece, take the rest of this, and we're going to create a user certificate to be used by Virtual Center. Basically, we're going to take that user certificate, and we're going to add it into Virtual Center. You'll see here, I'm kind of jumping ahead. But that's going to establish a mutual authentication between us and Virtual Center for establishing and communication and exchanging key information when needed by Virtual Center. So now we're logging into Virtual Center. We're going to come in and start enabling and go to the area where we need to add the key manager into Virtual Center. So click on Configure, Add KMS. We have none in there yet. You'll give the name of the cluster. It doesn't matter what you call it. You can call it HyTrust. You can call it the name of your company, -KMS, whatever you want to call it. Enter the information in about it. Leave the username empty, or leave the username or password empty. Hit the follow through the prompts and hit Trust. Now we've got a single appliance. I'll talk a little bit more about how not to use a single appliance outside of your lab environment. But now what we're doing is we're taking that certificate, we're downloading it, we're uploading it into Virtual Center, and now you'll see here, I flipped past it too fast on the screen here, but there's now an establishment of trust between the two. Now we're going to come in and enable vSAN encryption. It's actually as simple as just clicking that box and making sure that the HyTrust appliance is in there. At that point, what you'll see is the disks are all going off and being encrypted inside the appliance. One thing that I didn't show in the video, and I recommend, there's an option to format the disk. So when you enable encryption or vSAN encryption, there's an option to also format the drives. I recommend that you also format the drives. So basically, what's happening is we've established a trust between our appliance and Virtual Center. We've gone in and enabled encryption on the vSAN appliance. Basically, at that point, it's going to take all the drives inside the vSAN hosts that are there, empty or drain any VMs off of that disk that were there, format that drive is what I'm going to recommend, encrypt that drive, and then they're going to start moving data off of another drive onto that encrypted drive. So any data that moves to the new encrypted drive is automatically encrypted, and they'll rinse and repeat until they go through all the drives in the vSAN cluster in that instance. It's actually as simple as that. vSAN encryption is a no-brainer, and let's plug for myself, it's a no-brainer to install our product. I didn't show the full installation, but getting it up and running for a brand new customer is usually about 30 minutes. My coworker who talks a lot about key control will say it'll take you about an hour, and that may be right because you'll read all the prompts and maybe read some documentation. But it really is going to take no more than an hour to get it up and running. So any questions about that before I jump in? Go ahead. Yes, it is. Yep. So the communication between vSAN or vCenter and a key manager is TLS encrypted as well. Yep. So now that's about enabling encryption inside VMware products. We just talked about vSAN, but we can also enable encryption at an individual VM inside vSphere, and that's called, I refer to that as vSphere encryption. So based on adding the KMIP or the server to Virtual Center, you now assign, you create an encryption storage policy, and now you then go and apply that policy to individual virtual machines if you're not running on top of vSAN, for instance. And then you decide whether or not you want to do all the disks for a VM, or you can pick and choose your VMDK that you'd like to have encrypted. One thing that's great in technology, but what if you want to start moving that VM off to somewhere else? You want to make sure that it's encrypted when it gets backed up, or you want to make sure it's encrypted no matter whether it gets downloaded. Someone decides they want to download the thing off the data store. With data control, this is where we extend across all the clouds out there. We can make sure to install a policy agent, which also provides different policy controls, different than what's available in vSphere and vSAN, to make sure that the role-based access controls and different things such as rotating keys on a periodic basis, making sure what happens with keys when they reach their lifetime. Do we just archive them, or do we actually delete them? And when I say delete the key, when you tell us to delete it, we will ask you, are you really sure you want to delete this? And when you get to the end of us asking you several times, do you want to delete it? When we delete it, it's gone. The only way, if you decide after that, to get that key back is to bring back a backup of the appliance that still had the keys sitting inside it. So with that, I'll pause too and make sure that we're all building highly available infrastructures. You're probably using Active Directory, DNS. You have all kinds of redundant systems in your environment. Key management has the same high availability rules associated with it. You don't want to install one appliance inside your environment. Just like you would never install, or you should never install, a single domain controller. You should never install a single DNS server, yada, yada, yada. I can keep going on to other systems inside the environment. Key management is imperative, and actually we will not sell you less than 2 nodes at a time. We're only going to sell you 2 of them. If you so choose to deploy only one of them against our best practices, and then you run into a problem, we won't tell you that we told you so, but I'll tell you today that I told you so not to do that. We recommend to have 2 of them in each site, so have a pair in the primary site and a pair in the secondary site. You'll join them logically together to have a 4-node cluster, so that'll give you the ability, if a VM that's been encrypted in a primary site is being replicated through SRM or Zerto or whatever other method you're using to get it to the DR site, when you bring it online, you'll have a pair of nodes over there that VM will be able to decrypt itself as it powers on. With the data control policy agent, what we can do is encrypt inside the virtual machine, differently than what VMware is doing for the vSAN or the vSphere encryption. So our encryption, when using our data control policy agent, follows that VM no matter where that VM moves. So if you want to move it to another encrypted vSAN data store, or you want to add encryption on top of use the vSphere encryption on top of the data control policy agent encryption we're doing, rock on with yourself. Frankly, there's really no reason to do double encryption nowadays, but some people feel really comfortable doing that. The policy agent is FIPS 142 certified. It also supports HSMs, which I mentioned earlier in the presentation. It allows you to encrypt VMs, whether they live on premises or in the cloud. And the nice thing about this is it gives you the ability to always own your keys. One of the things that I'll talk about, and I'm not going to bash any of the cloud vendors out there, they all provide encryption. However, they also have access to all of the keys on the back end. Yes, there are processes they need to go through in order to gain access to your keys, but if they get subpoenaed, they need to notify you that they have just been subpoenaed and they're going to hand over your keys to the authorities. Using Data Control Policy Engine, you maintain ownership of those keys 100% of the time. If you encrypt the virtual machine using HyTrust and move it up into AWS, AWS has absolutely no way to get access to that data on that VM. You always control that data and the encryption keys for there. We also provide OS access level controls inside using our Data Control Policy Agent. What's really cool about this is, as a sysadmin, I used to be a domain admin in my organization. I can grant myself powers that I don't really have, or I can grant myself access to data I shouldn't normally have as a domain admin. Well, if the data is encrypted, you want to make sure that the encrypted data that we've already locked down properly with the cloud VM sets, make sure that the domain admin is not granting himself access to financial data inside the organization. So with our OS-based access controls, we can prevent sysadmins from accessing encrypted partitions inside the VM. We can also specify who can and cannot access that data. And I've done this in my lab several times. I don't have a video to show it. But even though the domain administrator is on the ACL for accessing an encrypted volume, we will make sure that that domain admin, despite what the ACL says, can't access that encrypted data going forward. And this works, once again, not only on premises, but up in the clouds as well. We support Windows and Linux. I didn't really talk about that yet, but we support Windows and Linux operating systems. We go all the way back to, I think, 2012, whatever the latest version that's still supported by Microsoft, we support. Same thing with Linux. I have a whole list in our product documentation. You can find out what we support. I kind of jumped ahead. This is talking about how would you deploy or build a highly available cluster. Put some in your primary data center, a pair in your primary data center. Or if you'd like, put them up in a cloud or a secondary data center somewhere else. So that's our recommendation. I'm going to stick by it. I'm not going to talk about pricing. If you want to talk about pricing, Kevin just came in the room. After I'm done, we can go. He can talk with you on how to license it and purchase it. So with that, any questions around encryption? Did anyone see the, good hands, right? He was first, I'll let him go.
If I have an next-gen firewall that needs deep packet inspection, how do I go like it?
So we will work through the fire. We can work through the firewall. You can do deep packet inspection on the keys that are coming across. The data itself, so we're doing at-rest encryption. So once the VM powers on, when an application asks for the data or you decide to do a copy of the data from an encrypted partition to either another encrypted partition or a non-encrypted partition, that data is going across the wire in an unencrypted format because we're just encrypting the disk under the covers. So as someone asks for the data, we decrypt it, provide it into the OS level and the application up above there. Does that answer your question?
So the data in transit is not encrypted?
Yes, so we do not do data in transit encryption. How do I say that, Glenn? So you need to, in order to do data in transit encryption, you need to use some other technology. So if we're using SMB, let's pick that for instance. SMB3 protocol has native encryption built into it. Most people do not turn it on because they're afraid of any sort of performance impact. But you could do data encryption in flight through SMB3 if you'd like to. And I don't recall what NFS provides today. And then when it comes to HTTP, if you want to do an HTTP transfer off of something, once again, the application is going to ask for the data, pull it off, we're going to decrypt it, and it's going to go across the network. Hopefully you're using TLS at that point. That help answer your question? Okay, great. You had a question as well.
Do we have capability of encrypting a specific folder within the VM? Or entire drive, but leave the operating system drive unencrypted?
Yeah, so the question is, can we do folder level encryption, or can we, with data control, pick and choose which drives we want to have encrypted? The answer is yes. We do provide some level of folder level encryption through OS access controls and protections. You can also decide to just do the data drives inside of VM if you'd like, and say the heck with the operating system. Excuse me, don't care. But one thing that's really interesting now that you brought up the topic, we are one of the only two vendors who can actually encryption vendors who can actually encrypt the boot drive for VMs as well for domain controllers. So it turns out the only other one, surprise, surprise, is Microsoft. So if you have a domain controller, we actually encourage people, and actually one of our very large retailers that most people have heard of around the world has decided that they... Oh, was it down there? Oh, I'll take your word for it. Yeah. So they were up there. All right. Yeah, the one that starts with a W and ends with a T. That's right. So it turns out they realized that their domain controllers basically have the keys to every employee inside the organization. So they wanted to make sure that as they shipped domain controllers and powered them on around the world, that the domain controllers at all costs were always encrypted. So that if a domain controller got in the wrong hands, that data was always encrypted for them. So in a long-winded way, we can do folder-based protection through OS access controls. We can also make sure that you can pick and choose which VMDK or disk you want to encrypt. We can provide boot-level encryption, and that's both for Windows and Linux operating systems. And we're one of the only two vendors that can provide boot-level drive encryption for domain controllers. You would think, what's so hard about that? But it turns out that it's actually more complex than I actually thought it was. So it makes sense why there aren't very many people that can actually do it today.
So another question, how about encrypting physical machines?
Encrypting physical machines. So we do not encrypt physical drives or physical appliances today or physical machines. If you'd like to if you have an application running on a physical machine, one of the things, and we've helped many customers do this, is take a physical machine because you want all the horsepower for that machine, is my guess. You want all the RAM, all the CPU, and the disk I/O on the back end. And you want to make sure that application always has that. What we suggest is to install just vanilla ESX on the box. P2V your application into a virtual machine, run it on there. ESX is really low overhead, to be honest with you. The application will then basically have all the same control of all the hardware under the covers again.
I was thinking mobile devices.
Yeah, so mobile devices, we don't do any support for mobile devices. Yeah, sorry about that. Yeah, no individual endpoints. So let's pick laptops, tablets, cell phones. We don't do any of that today. Yep. All right, so let me launch into cloud control. Great questions. Thank you very much. So I have a couple other questions here. Do you have dedicated virtualization teams in your organization, or is it, are you a couple guys that are doing everything inside your organization? Kind of hands? So it sounds like a lot of you folks have multiple hats. Is that a fair statement? Okay. Well, so let's keep going with my question here. Do you guys have ways, say another individual comes into the group, do you all share the same root password for your ESX hosts? I see a combination of yes and no. So I'm going to go down the yes way, as that's not a good thing to be doing when it comes to security. Auditors do not like that. I'll let you know that. And that's one of the areas cloud control can help, and I'll talk about that in a second here. What are you doing today for compliance? I mentioned today, something to think about. We don't need to answer it here. We can talk about it afterwards. We can provide continuous compliance for your virtual environment, just like I talked about for the cloud environment or cloud container environment. And then how many times have you guys made an oops, like you accidentally powered off a virtual machine because you right-clicked on the wrong VM? Yeah, I'll tell you what, I did it. I will tell you right now that I've actually accidentally powered off the wrong virtual machine. Back in my day, I also accidentally unplugged the wrong physical machine, but that's a whole different time. We're not in those times anymore. These are questions that we'll be able to answer through Cloud Control. So Cloud Control, customers depend on us for helping to prevent accidental downtime, powering down the wrong virtual machine, maybe even deleting the wrong virtual machine. Stopping insider threats. I talked about insider threats with key control, how you should split up the admin key. We can talk about how to do that with Cloud Control as well. Automating the compliance tasks. We all have different regulations we need to abide by, even if they're not the big ones that I mentioned, PCI or NIST or HIPAA or any of those. There are different compliance tasks that every organization needs to abide by, and we give the ability to either take what we do and customize it or build something from the ground up. We can help you meet your data security and privacy regulations, not only with the combination of key control and data control, but also with Cloud Control together. And we help secure those multi-tenant environments, as you've heard already. So I'm going to show a real architectural diagram of this is how things work today in a virtual environment. We've got our admins on our left-hand side that are logging into Virtual Center. They're powering on, creating, deleting virtual machines. They're also doing stuff through VRO, VRA. That is going back into Virtual Center, and then all the operations are being pushed down to the host to do whatever needs to be done in order to help with that. There are some role-based access controls in Virtual Center, and then there are the only actions today in Virtual Center that are logged are the ones that you've attempted to do. There's not a good way today in Virtual Center. They're getting better at that, but there's no good way today to see what actions were actually denied. So that's where Cloud Control comes in. Cloud Control is a transparent proxy that basically sits in between the admins and the orchestration tools out here. And basically, when a virtual machine, when you log in, you're logging into our appliance. We're going to hand off the authentication to real Virtual Center on the back end, figure out that it's you, and then you're going to continue to work through our appliance, and you'll see all the same stuff you see in Virtual Center. We'll actually have the ability, based on our security policy that we build inside the appliance, to either show or not show certain things. So if it turns out you've got a very senior admin and you've got a very junior admin, well, there's a certain set of virtual machines you don't want your junior admin to even know exist because you don't want them to accidentally power those off or delete or do something bad inside your organization. With our product, we can actually hide that from the view altogether, which is a pretty cool feature. We can also, through the policy engine, when you do that operation to say power down a virtual machine, it'll go through our policy engine. The policy engine will see, hey, did we give Dave the ability to power down the virtual machine? And the answer is no. We're not going to forward on that request onto the real Virtual Center on the back end. The answer is yes, you have the ability to do that. Then we automatically send it back into the Virtual Center. So we have a very flexible policy engine. All those actions that I just talked about are completely logged, even the denies. So if it turns out you're not allowed to do a power off operation, we'll log that you attempted to do it, and that actually makes the auditors happy in certain regulated industries as well. Quick question.
Do you alert the user that, hey, you don't have permissions for this action?
That's a great segue into a video I'm going to show you in a couple slides here. So the question was, do I alert the user that they are not able to do that? Quick answer is yes, and you'll see how we can fix that. So we apply all these controls and monitoring with no impact to the users, and it's not in line with the production network, so there's no impact on availability to this information. So our product is working around the two core tenets of security. That's principle of least privilege and separation of duties. In your organization, it sounds like separations of duties is not that big of a deal, but I will tell you, I work with a lot of bigger organizations, banks. They are crazy with the amount of separation of duties and least privilege access inside the organizations. And we have sold into 3 of the top 5 banks inside the United States and one of the top 3 banks in Canada today. They are using us just for the extensive logging and some of the product features I'm going to show here shortly. Cloud Control provides strong administrator access authentication through Radius and 2-factor login, so we can do it through Radius or RSA. You can also do Virtual Center provides RSA authentication as well. We can provide an additional if you're not using our additional factor through Radius if you're not using RSA. Secondary approvals. This is getting to the question asked: how do we show the customer what or the user what they tried to do they weren't allowed to do? Secondary approvals are very cool. We actually had a great story. A customer we were talking to, well, we were hoping they were going to be a customer. We were talking to said, yeah, we're all good. We're okay with what's happening inside Virtual Center. We've got everything, all of our rules defined, all of our access controls. We're all good to go. It turns out a couple days later, this is a big mortgage company. They do something in the range of like $8 billion a day transaction. It's some ridiculous amount of money that they transact. They had an administrator, a good administrator, and works well for them. He was going to run a script to do something and to get some information about the virtual environment. Instead of doing a get in his script, he did a put, and that put went and powered off 300 plus virtual machines inside the environment in no time flat. When that happened, their $8 billion went down to barely $500,000 they transacted in a day. They lost $7.5 billion in money that day that they were able to get done. They called us very quickly after that happened and are now using secondary approvals. Secondary approvals, the way they work, using the policy engine, basically administrator comes in and says they want to add storage, goes through the policy engine. They can now have the ability to do that. And at that point, that operation succeeds. If they want to delete a virtual machine, the policy engine comes in and says they're not allowed to do that. But the secondary approval says that now we need to have an administrator or several administrators approve that operation. We can do the same thing for NSX. And I'm going to jump through a video here to show how that works. So this is a video showing how secondary approval works. We're going to attempt to power off a virtual machine. This administrator doesn't have the ability has the ability to do that. However, we want to make sure that he's powering off the correct virtual machine. So at that point, he gets the notification that he was unable to do that, and secondary approval has kicked in. At that point, the administrator, the approval administrator, is going to get a notification in his email that, hey, I've got to go allow this or approve this for my user. They're going to approve that operation. Click Apply. You can also set the time when you want this to happen and for how long you want it to happen, so it's good for maintenance periods. Now the user has been granted access. Their secondary approval was approved. They're going to power off that virtual machine, and voila, it works just fine and dandy. So secondary approval is a great way to stop stupid and to stop big accidents from happening inside your environment. I'll quickly jump over separation of duties. We provide rich role-based access controls. We can actually take some of the rules that are in Virtual Center and NSX and break them out into even finer grained pieces. And you can build these operations, this policy based on ones we already have. I'm going to jump over this because I'm going to give some time for the next presenter. The policy agent gives you the ability to provide that logical segmentation. This is showing how to keep all PCI VMs from ever touching a non-PCI environment. So what we're showing you here is we've got an administrator who's going to try and connect a port group on the marketing non-PCI environment to a PCI port group in the PCI environment. He tries to do that. It turns out the policy engine says that we're not allowed to do that, and we can stop that. And once again, the admin is going to be notified that that happens, and that operation will be logged. The compliance engine, once again, it helps you. You can define it to start with, or you can take one of our built-in 20 plus compliance templates and customize those to your organization. We also provide root password vaulting for those folks who are answering yes, they share their root password with everybody. Root password vaulting is a good operation to make sure that your auditors are now very happy to see who is logging in and doing things that they're not supposed to be doing. By using Cloud Control, we're locking down things from the UI, but you also have to make sure that things are audited from the back end when you're not using the UI, and root password vaulting is one way of doing that to see that someone elevated their processes or privileges inside the ESX host. The logging engine is very extensive. It will actually show you what's very cool is before and after. So if someone says, I didn't power off that virtual machine, it was always running, we can actually show that before the actual virtual machine was running, and you logged in and powered it off. So we can show you the before and after state. And we work with all these different event syslog or logging tools out there in the market. So to sum it up, VMware and HyTrust work very well together. We can help secure that stack. We're now extending that across the full stack protection, not only in VMware, but also in the cloud, as well as in the container space. So with that, if you have any questions, please hit me up afterwards. I'll share this presentation with you guys, and we can talk with you as well. So let me, I'll stop there real fast. Any questions? Okay, great. Thank you very much, guys.